problem number 9. So I want to warn you, if you have the original copy of the exam review, it has a -4 instead of a -1. That problem is still doable, but it's significantly harder than I would have intended. So here is something more akin to what you might see on the exam. So use the intermediate value theorem to show this equation has a root in 0, 1. So what do we mean when we say has a root? We just say this function is equal to 0. It has some x where that happens. And how can we use the intermediate value theorem to do this? Well, first we need to state that this function is continuous. So if I call this f of x, you specifically need to state f of x is continuous on 0, 1. As a matter of fact, it's continuous everywhere, but this is what I need to apply the intermediate value theorem. What do I do from here? I try to plug in a point, one that's bigger than 0, or one where the function is bigger than 0, and one where the function is less than 0. So let's go ahead and try that. Usually it's good to use the endpoints. We had a homework where that wasn't the case, but we'll see if it works here. So f of 0 is -1, f of 1 is 1 plus 3 minus 2 minus 1 equals 1. So I have f of 0 is -1, f of 1 is 1. So by intermediate value theorem, there is a c such that f of c is equal to 0, which is exactly what we want. So we've done it. We've shown that there's a root. As a matter of fact, we can say a little bit more, even though it's not particularly useful. But we could pick any number between -1 and 1 and say that there's a c where f of c equals that number, because that's what the intermediate value theorem states, is if you can find two different values, then you can find any value in between. We just usually use it to find zeros, so that's kind of the context there. But that's how to do one like number 9.